This section introduces the steps in streaming ingestion and the tools that can help you perform them. With streaming pipelines, the main steps of the ingestion process involve producers, a data stream, and consumers. Producers put records on the stream, and the stream provides durable storage from which consumers can get and process records. Consumers read records from the stream and process them in batches. The results of the processing are made available to analysis and visualization tools for real-time analytics or might be stored for later analysis. This slide summarizes the characteristics for streaming ingest and stream processing pipelines as described in the Data Analytics Lens AWS Well-Architected Framework. Streaming is a rather distinct way to work with data and can feel complex quickly. The goal at this stage is just to recognize the types of considerations that you need to learn about when using streaming methods. AWS and other providers offer services that are specifically designed to ingest, process, and store streaming data for analytics. This slide looks specifically at streaming ingestion by using Amazon Kinesis services. Amazon Kinesis Data Streams is a streaming service that meets the characteristics from a previous slide. The service continuously captures gigabytes of data and supports multiple sources and targets in parallel. A stream can scale up and down and encrypt sensitive data automatically. Kinesis Data Streams also provides mechanisms to manage the success or failure of stream processing. This high-level diagram highlights two paths for streaming ingestion. In the top path, streaming data is collected into the stream and stored for future use. In the second path, data is processed as it is ingested to feed real-time analytics. In the example on the slide, a combination of services from the Amazon Kinesis family provides the pipeline infrastructure for these streaming applications. Producers put data onto a Kinesis data stream, which provides durable storage for the data. More than one producer can write to the stream. Consumers get the data from the stream and process it. The stream is kind of a buffer between the incoming data and the processors of that data. A stream can have multiple consumers. AWS has developed additional streaming services that are purpose-built to consume stream data for common scenarios. Amazon Kinesis Data Firehose for streaming data to data stores, and Amazon Kinesis Data Analytics for real-time analytics. Some AWS services can directly write to the stream. For other producers, you need a producer application to capture streaming events from the producer and put them on the stream. The Amazon Kinesis Producer Library, or KPL, simplifies the coding that is required to write a producer application. Data is put onto a Kinesis data stream as data records, and records are stored in shards. Each record includes a unique sequence number, partition key, and data blob. The partition key will determine which shard the record will be written to. In addition to the purpose-built stream consumers that were mentioned earlier, you can also build consumer applications by using the Amazon Kinesis Client Library, or KCL, to read data from the stream and process it. Custom consumer applications can run on Amazon Elastic Compute Cloud, or Amazon EC2, instances. AWS Lambda functions can also be consumers of a stream. This option provides serverless processing of stream data, and Lambda handles aspects of error handling and stream management for you. Streaming ingest and processing systems need to be secure by default. You can configure Kinesis data streams to use AWS Identity and Access Management, or IAM, policies to grant access and encrypt sensitive data automatically. You will need to use the principle of least privilege to grant access to the streaming APIs and infrastructure, and encrypt data at rest and in transit. Kinesis Data Firehose is designed to ingest and deliver streaming data directly to data lakes on Amazon S3, as well as data stores and analytics services such as Amazon Redshift and Amazon OpenSearch Service. Kinesis Data Firehose also has the ability to run built-in transformations or custom transformations that you create by using a Lambda function that runs on the streaming data before it's delivered to the specified location. A common use case for Kinesis Data Firehose is to convert data into the format that is required for analysis and stream it to your data lake without needing to build any other pipeline components. Kinesis Data Analytics is purpose-built to perform analytics on streaming data as it passes through the stream and deliver data directly to tools for real-time analytics. For example, you might perform calculations to derive new fields or to aggregate values over a sliding time window within the incoming stream. You could then write the results to OpenSearch Service, where the results are available for Amazon OpenSearch dashboards or other analysis and visualization tools. You can integrate a data source or destination with minimal code by using Kinesis Data Analytics libraries to integrate with AWS services, including Amazon S3, OpenSearch Service, DynamoDB, Kinesis Data Streams, and Kinesis Data Firehose. Apache Flink is a popular framework and engine to process data streams, and Kinesis Data Analytics provides the underlying infrastructure for your Flink applications. It handles core capabilities, such as provisioning compute resources and automatic scaling. You can use Java, Scala, or SQL for your Flink applications. Kinesis Data Analytics Studio runs on and produces Flink applications and provides the ability to code in notebooks by using SQL, Python, and Scala. A notebook is a web-based development environment that provides a simple interactive development experience combined with the advanced capabilities that Flink provides. This makes it easier to perform more advanced analytics without as much coding expertise. Here are a few key points to summarize this section. In streaming scenarios, the stream provides temporary storage and is a buffer between the producers who put data on the stream and the consumers who read and process data from the stream. The Kinesis Producer Library, or KPL, simplifies writing producers that put records on a Kinesis data stream. Stream records are stored in shards and include a sequence number, partition key, and a data blob. Kinesis Data Firehose is designed to deliver streaming data directly to storage. Kinesis Data Analytics is purpose-built to perform analytics on streaming data for real-time analytics. This section looks briefly at scaling considerations for stream processing pipelines. Managing scale for your streaming pipeline is about managing throughput. Remember that the stream itself provides temporary storage, so you want to make sure that all the consumers that you need to act on records in the stream can complete their work before the record expires and is gone from the stream. If consumers are having difficulty completing processing before records expire, you could increase the time that records are available on the stream. Beyond that, you want to optimize how quickly you can write records to the stream and consume them off the stream to make them available for analysis. You need to think about how much data you are going to write to the stream and at what velocity, as well as how many consumers need to read data from the stream and how quickly they need to get the data. When you start using your stream, use metrics to check that processing is not being throttled. This would indicate the need to address the write or read capacity of the stream. Metrics that highlight expiring records can help you ensure that your stream is keeping records long enough for your consumers to get to them and complete processing. Kinesis Data Streams provides configuration options to help you address the scaling needs of your pipeline. Here is a summary of the 3 primary controls. The retention period tells the stream how long to keep records on the stream before they expire. This is configurable, but costs increase as the retention period increases. A stream's retention period is set to a default of 24 hours. You can increase the retention period up to 365 days. The write capacity is controlled by how many shards are allocated to the stream, which sets the limit on how much data can be written to the stream in a given period. You can choose either on-demand or provision capacity mode. Data streams that use on-demand mode require no capacity planning and automatically scale to handle gigabytes of write and read throughput per minute. With on-demand mode, Kinesis data streams automatically manages the shards to provide the necessary throughput. If you choose provisioned mode, you must specify the number of shards for the data stream. The total capacity of a data stream is the sum of the capacities of its shards. You can increase or decrease the number of shards in a data stream as needed. Read capacity scales the throughput for consumers of your stream. You can choose between shared fan-out and enhanced fan-out consumer types. When a consumer uses the shared fan-out configuration, it shares a single pipe of read capacity with other consumers of the stream. The enhanced fan-out configuration gives the consumer its own pipe, which increases the throughput for that consumer. Both CloudTrail and CloudWatch are integrated with Kinesis data streams. The metrics that you configure for your streams are automatically collected and pushed to CloudWatch every minute. The student guide for this slide includes additional details about the metrics that are recommended for your Kinesis data streams to align to the scaling considerations that were discussed on the previous slide. Here are a few key points to summarize this section. Kinesis data streams allows you to scale how long data remains on the stream's read capacity, and the stream's write capacity. Use CloudWatch metrics to help you monitor how your stream is performing. IoT data is often ingested by stream, although you could ingest this data by batch. This section introduces key concepts for ingesting IoT data by stream using AWS services. The IoT universe is made up of many different devices. They communicate to cloud resources to provide information about what is happening in their environment, and these devices can receive commands from cloud resources to modify their behavior. For example, a smart plug sends information about itself, where it is, what it is, whether it's on or off, to the internet, where you can access it on your phone. You can use the app to tell the smart plug to turn itself off, and that is communicated back to the device. You can break the main components of the IoT universe into 5 categories: devices, interfaces, communications, cloud services, and apps. Devices communicate with each other and with cloud services through a variety of technologies and protocols. For example, a device might send information by using a protocol, such as HTTP, traveling over the cellular network. The contents of the messages that IoT devices send might be semi-structured or unstructured. One common protocol for IoT is Message Queuing Telemetry Transport, or MQTT. This lightweight protocol uses a publish-subscribe, or pub-sub, model to send and receive messages. The advantage of using MQTT for IoT is that it requires a small code footprint and very little bandwidth, which is important for small, remote devices. The advantage of a pub-sub model is that it decouples the message creators from the message consumers. Publishers don't need to know about the subscribers. They just publish to the topic. Likewise, subscribers don't need to be directly connected to the publisher. They subscribe to topics of interest. This is especially helpful for IoT devices that are not continuously connected to the internet, or for those that experience unplanned disconnections. With this model, devices send and retrieve messages when they are online. With IoT devices, a device might be a publisher and a subscriber. For example, the IoT device attached to a light sends a message that it's on, and your smart home app is a subscriber to that topic. When you send a command to turn the light off, the device is a subscriber to a topic that gets the message and turns the light off. To discuss ingesting IoT data into an analytics pipeline, the rest of this section looks only at the messages that come from a device and are delivered to cloud services, where they can be used for analytics and ML applications. IoT data is often ingested as streaming data, given that many devices usually feed into a single pipeline, and that messages from those devices are generated every few seconds or minutes. The full set of AWS services for IoT are described in the AWS IoT Services Overview section of the AWS IoT Core Developer Guide. A link is included in the course resources. The two services on this slide are especially relevant to ingesting data for analytics. With AWS IoT Core, you can securely connect, process, and act upon device data even when devices are offline. AWS IoT Core is at the heart of IoT solutions that are built to run on AWS. The AWS IoT Analytics Service simplifies the steps to build a sophisticated data pipeline for unstructured IoT data. The service has features to perform the data transformations and to store time series data that other tools in your pipeline can analyze. The next few slides look at these two AWS services in the context of ingesting IoT data. AWS IoT provides the cloud services that connect your IoT devices to other devices and AWS cloud services. AWS IoT Core is a subscriber to messages that IoT devices publish. The service uses rule actions to deliver messages to other AWS services. AWS IoT Core includes the following key features. The device gateway serves as the entry point for IoT devices to connect to AWS. The message broker provides a secure mechanism for devices and AWS IoT applications to publish and receive messages from each other. The rules engine uses rule actions to route messages from the message broker to other AWS IoT services for storage and additional processing. The Content Resources section of your course provides links to go deeper into these and other AWS IoT Core topics. The next slide looks more closely at the Rules Engine. The Rules Engine listens for topics coming into AWS IoT Core and applies any rules that you have created for that topic. You create rules that include a name, a SQL statement that indicates the relevant topic, and one or more actions to be taken. The SQL statement provides a way to filter and transform the original messages that come into a specified topic. You can limit which message attributes to include and can describe conditions about which messages to include. You can also augment messages with additional attributes. A common scenario for ingesting IoT data to an Amazon S3 data lake would be to use a rule action to route messages to a Kinesis streaming service, such as Kinesis Data Firehose. Then, set up Amazon S3 as a consumer of the Kinesis Data Firehose stream. You could also use Kinesis Data Firehose features to transform your data further. For example, you could run a Lambda function on the messages and convert the file format before delivering the data to Amazon S3. Consider the streaming pipeline scenario that is described in the Kinesis for Stream Processing section of this module. The messages from AWS IoT Core are producers of data that is destined for a stream, which is then consumed by another service. Using the terminology that you learned earlier about streams, AWS IoT Core is the producer and Amazon S3 is the consumer. Similarly, for real-time analysis, Kinesis Data Analytics could be a consumer of a Kinesis Data Firehose delivery stream and could perform real-time analytics to feed real-time dashboards. AWS IoT Analytics is a fully managed service that automates the steps that are required to analyze data from IoT devices. The service filters, transforms, and enriches data before storing it in a time series data store for analysis. The service has multiple components. A channel collects data from a topic, in this example from an AWS IoT core rule, and archives unprocessed messages before publishing the data to a pipeline. A pipeline consumes messages from a channel and performs processing on the messages before storing them in a data store. Pipelines store their processed messages in a data store. The data store is not a database, but it is a scalable and queryable repository of messages. You retrieve data from a data store by creating a data set. The data set contains the SQL that you used to query the data store. You can send the data set contents to an S3 bucket to integrate it with your data lake. AWS IoT Analytics also supports direct access to your data sets from Amazon QuickSight so that you can easily visualize your data set without additional services. Here are a few key points to summarize this section. IoT devices use a pub-sub model to communicate with each other and with cloud-based services. In a pub-sub model, publishers send messages to a topic, and subscribers subscribe to that topic. A message broker routes published messages to the correct subscribers. AWS provides many services to support the IoT universe, including AWS IoT Core and AWS IoT Analytics. AWS IoT Core provides features to support ingesting and transforming IoT data into your pipeline. AWS IoT Analytics provides a complete ingestion and processing pipeline. This section summarizes what you have learned and brings the module to a close. This module focused on the processes to build an ingestion layer that supports batch or stream processing. This module reviewed AWS services that simplify performing batch ingestion tasks, including Amazon AppFlow, AWS DMS, DataSync, and AWS Data Exchange. You learned how AWS Glue can help you to automate batch ingestion, and you looked at features of Kinesis streaming products that support streaming ingestion. You also heard briefly about the options for scaling the throughput of AWS Glue jobs and Kinesis data streams. Finally, you learned how AWS IoT Core and IoT Analytics can be used as part of ingesting and transforming streaming IoT data. Here is the sample exam question for this module. A data engineer is creating a stream processing pipeline that needs to reformat incoming data from CSV to JSON before delivering it to an S3 bucket. They are looking for the option that requires the least amount of coding. Which service would you recommend for this use case? What are the key parts of this question? Here are the key words and phrases in the question. The question notes that you are building a streaming solution and that you need to reformat the data before saving it to Amazon S3. The question also notes that the data engineer is looking for the option that requires the least amount of coding. Now, let's look at the answer choices. A, use Kinesis data streams. B, use a Kinesis data analytics Flink application. C, use Kinesis data firehose. D, use the Amazon Kinesis Client Library, or KCL. Based on the keywords that were identified in the question, which answer is correct? We'll pause a few seconds before discussing the correct answer. If you need more time to consider the answer choices, pause the video. The correct answer is C. The data engineer could build a consumer for Kinesis data streams to perform the transformation by using the Kinesis Client Library, or KCL, but this is not a low-code option. This solution also wouldn't enable saving data directly to Amazon S3. This means neither choice A, use Kinesis data streams, or D, use the KCL, is the best option. Kinesis data analytics applications can be written by using Flink. Such applications are used to perform queries and analysis on streaming data as it passes through the stream. However, this service wouldn't be the best choice for the simple format transformation and delivery to an S3 bucket. So choice B, use a Kinesis data analytics Flink application, is not the best option. Kinesis Data Firehose is designed to perform common transformations on streaming data before delivering it to destinations, including Amazon S3, while requiring little or no coding. Therefore, choice C is the best option. That concludes this module. The Content Resources page of your course includes links to additional resources that are related to this module. Thanks for watching.